So I started out my day with Hex Clue, and this is part of my morning math. It's a way of introducing algebra to the sixth graders without them really knowing that they're being introduced algebra. So what we do is we take problems, algebraic problems, and we format them into squares so that they can see that they have two y's when the equation or the expression is 2y. They can see them separate. So we have 4 different equations, and the students are to determine the value of x, y, z, all as unknowns, and coming up with a solution. What's really neat about this is I start out with an equation that's pretty simple, pretty obvious, such as 4y. And because of their skills of division, they can figure out that 4y means that they have to divide by 4 to get the value of the 1y, and then they build from there. Even though some of the equations seem obvious, we still have students that stare at all 4 of them and not know where to begin. So what I do is see if the students, how many are struggling, and then I assign math tutors. And my math tutors will step up to give them a jump start or make an announcement. Well, if anybody's having trouble, I started with Hex Clue number 4 first. And then it gets the kids that might not be as math confident able to solve the problem. The beginning of the year, they were very simple problems, getting them to learn about the formatting. And as the year progressed, I inserted decimals and positive and negative integers and fractions and really mixed it up. The first time that they looked, they would panic and say, I can't do it. They'd drop it into the box and say, oh, this isn't so bad. It's just like what we did before. So I started the Hex Clue about halfway through the year when I felt that they had enough algebraic type skills that they could actually solve them. And I want you to set your first box only. Okay, and pause the side. So our equation is 3y plus z equals 21. On his picture, does he show 3 y's? Yes. Does he show a z? Does he show that his total equals 21? Is he good to go? Okay. Good job. All right, Matthew. Look at what's on the board. Look at your sheet. If you agree, give yourself a silent, got it. If not, make the adjustment. That's all right. Don't solve it yet. Don't solve it yet. No, math is jumping into your brain. You've got it. Okay, last box. Feeling confident? Look at that algebra problem that everybody's going, oh dear, I can't do that. Talk to me about what you're doing on this one.
2z plus 2x equals 2.
Okay.
So since I know 2z equals 3.
How do you know that?
I mean, z equals 3.
Okay.
So z minus z would equal 0, because 3 minus 3 equals 0.
But we don't have any subtractions in here. So you just told me that 2z is going to be 6 plus 6. Why don't you show me that on your work? Okay, so erase this. And you show me what you just told me, that z plus z equals 6 plus 6, right? So what is z plus z? Because z plus z equals 6 because you told me z equals 3, correct? Mm-hmm. Okay? So you know z plus z equals 6, so you know that 2z equals 6. Now what are you going to do?
Solve 2x.
Okay, so write your equation. 6, okay. Do you know what x is yet? Okay, then show me that you don't know what it is yet. How would you do that? If you don't know what it is yet, how do you show that?
6 plus x. 2x.
How many? And what do you know that's going to equal? What do you know that 6 plus 2x is going to equal? What does the equation say?
8x.
What does the equation say?
2z.
Equal 2z plus 2x equals what?
2.
Okay, so that's going to equal 2. Now what are you going to do?
Therefore, x equals 2.
Because 6 plus 2 plus 2 equals 2? Ooh, got some work to do. What can you do to get rid of that 6? Yes, how much? If you want to get rid of that 6, and right now you're adding it, what can you do to get rid of it?
6 minus 2.
No, you want to get rid of the 6. Right now you're adding 6. How do you get rid of it? What do you do then? First you add it, and then you do the inverse operation, right? And so what would you do?
8 equals 3, so 3 times 2 equals 6. 6 plus minus -2.
No. We want to get rid of that 6. What's the inverse operation of adding 6?
So then minus 6.
Uh-huh. So if you put 6 and then you subtract it, you have nothing on that side. The 6 is gone. Okay? So 6 minus 6. What else do you still have?
2x.
Okay, go ahead and put that in there. Plus 2x. Okay, equal what? Equal what?
2.
2. And what did you do over on this side? What did you do over here? What did you do right here?
Integers?
No, what did you do? Didn't you subtract 6?
Oh.
So no, don't change that. We're not doing anything with the 2. But remember, whenever we subtract 6 on one side, we also have to subtract 6 on the other side, right? To keep it balanced. So we're going to buy minus 6, subtract 6. Subtract 6. There we go. Now what happens with 6 minus 6?
It turns into 0.
Good, goes away, right? So what are you left with?
2x equals 2 minus 6.
Good, all right. So let's leave our 2x over here. So bring down your 2x over here.
Over here?
Mm-hmm. And what's 2 minus 6? Think of a number line. I'm going to come back. Okay? And you're going to think of a number line. You're starting at 2. I didn't have to come back. Okay? So if 2x's is a negative 4, what would 1x be?
-2.
You don't need me. One of the final pieces to the expressions and equations component that we're supposed to teach are two-step equations. Knowing that's where I need to get, I don't want that to be a standalone introduce at the end of the year type of lesson. I want the students to, over the year, try little bits and pieces of it. What's an expression? It's only one side. What's an equation? Oh, where both of the sides are going to be the same. So they're almost understanding it before they're formally taught it. I'm using the approach with the Hex Clue of letting them figure it out themselves, letting them problem solve how to solve it, talking about, well, if I do something on one side, I have to do the other, without it being a formula or a structured strategy that they're using. I'm letting them problem solve, figuring out the best way to solve that problem. And what I see is they're solving it hit or miss. Sometimes they make the wrong decision and they get themselves even deeper in a hole. Or sometimes they choose a method that actually does work and their end result is what they hope their end result would be. But I'm letting them figure that out rather than saying, this is a structure and this is the way that you solve a two-step equation. The students gaining confidence evolved during the year. They came into the class very afraid of ever making a mistake. They didn't want to try things. They felt if they got something wrong in the beginning that they were a math failure. They couldn't get it. And the way that I approach here is that we learn from our mistakes, or somebody else will learn from your mistake. They work together a lot. So sometimes there is a comfort in two people making the mistake, but when they're working together, they're a little bit more willing to make a mistake because now they have someone that will help them backpedal a little bit to say, oh, this isn't where we want to go. Look at what happened. And I think that was really important, allowing them to work with someone, to talk it through, to start building their confidence. As the year progressed, they're more willing to make mistakes. And as they're building confidence, they can start looking back to see where that mistake occurred rather than I'm throwing the whole thing out, I'm starting over again. Direct instruction has always been the method that I've chosen to teach. I was very comfortable with direct instruction in that I felt that I was in control of the classroom. I direct the students, they do what I say, math is good. In the last couple years, I felt more comfortable releasing some of the direct instruction to the students, allowing them to also be the instructors, because the way they choose to solve a problem may not be a way that I would have chosen to solve, but might make sense to their peers. And so my direct instruction is very interactive. It's a passing of the baton constantly in my classroom. And over these past few years, I've become much more comfortable. And this was hard for me because I visualize it as an out-of-control classroom. How am I ever going to get control back? But I find that the kids really are learning a lot faster. They're learning a lot deeper. They're willing to listen to their peers, and their peers are willing to talk it through and to share. And especially when some of the kids who are math neutral or math not confident is another way we talk, is I'm not quite math confident yet, Miss Perry. It's my math neutrals and my math not confidence that I want to be the instructors. I want them to tell the other students what they did and why they did it, because that's where the learning takes place. But my direct instruction is not traditional. It's much more interactive now.
You could also simplify it by putting like 2y in 2 of them and then y in 1.
Could I do that? Could I do a 2y, a 2y, a y, and an x as 26? Talk it over with your partner. What do you think? Is Kenny on or is Kenny not on?
It still works because 2y plus 3y plus y equals 5y.
It's just 2y and 1 squared.
It's the same thing, he just put it in a smaller.
He just
made it smaller. He made it a regular x. Decomposed.
Jayla, what's your thought?
I think it will work because it's the same thing. You still have 5y and you still have 1x.
You still have 5y and you still have 1x. Could Malcolm's setup work?
Yes.
Could that work?
Yes.
All right. Could this?
Yes.
Could that work? Why would that still work? We've never done one like that. Jordan.
Because it's the same thing as 5y plus x. And because it's the same thing as 5y plus x.
Because I still have 5y plus x. So any problem that you get, any algebra problem that you get next year, you can always throw it in a hex clue. Pure math and basic understanding of math is so vital to kids being able to move a little further in mathematics. And I see kids coming in not confident with the interaction of numbers, how they work together. And so I present them a program called 24 Wheel. And this was off of a program called First in Math that we used a couple of years ago. It is a puzzle where the students are given 4 numbers. And of those 4 numbers, they have to reach 24 in 3 equations. Now, the solution to equation number 1, which can only include 2 numbers, has to be used again. The solution in equation 2 has to be used again. And then the final solution has to be 24. So in essence, they're using 6 numbers, 3 steps to equal 24. When I first introduced this to my kids, I put it up on the board and I said, all right, I gave them basic instructions. This is what you need to do. 3 equations, 6 numbers, come up with 24. And they sat there and said, I can't do it. and I had maybe 1 or 2 students that could pull it together. But every day, the 24 wheel is on the board. Sometimes I make up the numbers myself. Sometimes I go onto the program, make them. Sometimes I go to my phone app, and I have a 24 wheel app, and I'll pick up numbers from that, and I throw it up there. As the year progresses, the kids live for the 24 wheel. That is the high point of their math, and they want to show how they came up with the numbers. And it's all learning how these numbers interact and what you can do to the numbers to get the numbers to change to what you want them to be. And that's the part that's fun too. For example, if I have the number 2 up there, I have a 2, and let's say I have a number 4. Well, my kids now know that they don't want the 2 to be a 2. They really want it to be an 8. So they put the 2 to the 3rd power, and voila, they have an 8. They see they have a number 7. They don't want it to be a 7. They'd really like it to be a 1. So they know if they put it 7 to the 0 power, that 7 magically changes into a 1. And so what the students are doing is looking at numbers, figuring out what numbers they need, and coming up with strategies to change those numbers mathematically appropriate to make it work. Sometimes they come up with ways I'm not so sure about in the math guru world is really appropriate. For example, they have the number 8. They don't want it to be the number 8, they want it to be the number 24. So they'll take that 8 and they'll find the cube root, they'll make that a 2, they'll square it, they'll make that a 4, they'll put a factorial sign after it, it now becomes a 24. Oh, and they multiply it times 7 to the 0 power, and they have a 24. And to me, that's where the magic is watching these kids take these numbers, transform them into numbers that are useful to them using a variety of mathematical strategies. And now what happens, I have kids walk in the door, they look on the board, and by the time of their seat, they have 3 or 4 24 wheels done. They write it down really quickly so they can be the first on the board to show what they've done. So where's your basic? Okay, so there's your basic. There's your exponent. There's your root. And there's your
Absolute value.
absolute value. Sweet.
Oh, and a factorial.
Oh, and a factorial in there too. Now what are you going to do? There you go. Okay, so now you're telling me that you're going to find the cubed root of 8. What's a cubed root of 8? 2. 2 squared is going to be what? 4. 4 factorial is what?
1.
Times 7 to the 0 power. What's 7 to the 0 power? 1. Equal 24. You rock, lady. Good job. I need someone who will put an exponent. An exponent.
Can I do the exponent?
Jayla, go. No, Malcolm, you've got a job. Go. Exponent? There you go.
That's the same thing.
Division.
Okay, division sign is fine. Good job, Malcolm. All right, go. Exponent. Quick, quick, quick. I need a root. When with a root. Emily, go. Far side with the root. Saba, root, over there. Make sure it's not Emily's. All right, let's see. 16 divided by 8 is 2. 7 minus 6 is 1. 2 squared is 4. Factorial 24 times 1, 24. Sweet. Sixteen plus 6 is 22. The cubed root of 8 is 2 times 7 to the 0 power is 2. 22 plus 2 equals 24. Sweet. Good job. I'm looking for another root. Another root. Jordan, go. Find a spot with another root. Okay. Let's see. Cubed root of 8 is 2 times 7 is 14. 16 minus 6 is 10. 14 plus 10 equals 24. Nice job, Saba. Okay, I'm looking for No, I'm looking for a surprise. I'm looking for the surprise one. Jasmine, go. Malcolm, you've already been up there. I got to give somebody else a chance. I know you are so excited. Christian, you've been up there. Oh, I'm looking for new bodies. Come on, Malcolm, you've been up. Abdul, you've been up. Brendan, go for it, Brendan. You've already been up there.
I need to check to make sure it's not up there.
Oh, you have another one? Do you have another one on your board?
Yay.
Jazzy, you'll go next. Oh my goodness. 8 minus 16 is a negative 8. 7 minus the absolute value of a negative 8 is a negative 1. Holy Toledo. Okay, wait. Come back. What do you, no, you're fine, Brendan. Jasmine, what am I going to do first?
The cube root.
Okay, then put the cubed root in parentheses.
Never mind.
Because otherwise I'm just a little confused. Okay, so the cubed root of 8 is 2. Then what are you going to do with that?
The second power.
Okay. Squared, which gives you 4. 4 factorial is 24 times the absolute value of a negative 1 is 24. Sweet. All right. What?
How did she get 2 8s?
How did you get 2 8s? She got the negative 8 in the second step from that negative 8 answer.
Yeah, but on the bottom one, the third one, how did you get that 8?
Oh, she got another 8. Where'd that come from, Jasmine?
That, negative 8. Oh, that's on the second one.
Can't make up your own numbers. You have a surprise? Jazz G, did you already put one up? Okay, go.
Can I do my
Can
other
you
one?
fix it? All right.
I can't fix this one, but
Okay.
I can do another one.
No making up random numbers. Every week, one of my math homework assignments is a problem solver. And a problem solver is a word problem, and I introduce a different strategy that works best with that particular problem solver. It may not be the only strategy that will work, but for example, maybe I want them to practice making a table, or making an organized list, or acting out with objects. And so every week the students are practicing these word problems with different types of problem-solving strategies. So once again, they have a repertoire of strategies they can use. With the performance test they took today, there were a number of different strategies they could have taken from their bag of tricks of strategies. So having a word problem like this wasn't new to the students. So when they looked at it, they weren't panicked. It's like, okay, this is the problem solver. Now what strategy is going to be the best one to use so that I can solve the problem? We do a lot of the problem solvers with support groups, meaning you don't have to do it on your own. We do a lot of teamwork in here. Maybe one student sees a strategy and likes that strategy. That wasn't the one they thought of, but whoa, I'm going to take ownership of that one. That's now going to become mine. So we do a lot of borrowing of strategies, of other people's strategies. So when they had the performance task and the problem solver, it prepares them for the testings that they're going to have at the end of the year. You are going to do what's called a performance task. And you have had these performance tasks before. They are kind of a word problem where you have extended steps. We do these with problem solvers. Those could be viewed as a performance task. And what we're going to look for is your work. So the strategy that you may not use is mental math. Okay? There's tons of other strategies that we've talked about and that you've learned. But mental math is not going to be an okay strategy on this one. Okay? Even though that's your favorite strategy, we have to throw that one out. Okay? So what I'm going to do is I'm going to pass these out. I'd like you to do the work on your whiteboard, and that way I can come around much easier and see it than looking on this small piece of paper. And you're going to show us the work that you are doing to try to solve this. This is not a test. It's a task. You're going to do the very best you can. And then we're going to stop, and we're going to talk about the steps that you took to solve or to start to solve the task.
What I attempted to do was
Your whiteboard, yeah, kind of.
I drew a picture. The top row is the go-karts, the bottom is the bicycles. So the dots are the wheels and the seats are the lines. And so there are 26 wheels and 9 seats right now.
Who can explain Alexis's, keep showing us Alexis, because that's a nice way to organize your data. Who can explain what she's doing in her data? There's a long line, then there's 4 little dots underneath it. What is that standing for? Talk to your neighbor about that. Who would like to tell Alexis what, we're just looking at the top, what does the long line mean with 4 little dots underneath? What is she showing on her data? Because this might help her figure it out. You want to call on someone?
The long line represents the seat. And
Oh, that's important, huh? And what else?
the dot represents the wheels, and the top ones are the go-karts, and the bottom ones are the bikes.
Oh, so she's paying attention to seats and wheels at the same time, not just wheels. Who wants to ride a bike without a seat? I don't know about that. I don't think I'd like to. Okay, thank you. What are you trying to do? Set up this chart for us.
Well, I didn't quite finish, but I was making a chart with the bikes, go-karts, and the wheels. And then I know that if I get 54 wheels, then I know I need to add up how many go-karts and how many bikes there are, and then that needs to equal 54, because that's how many seats there are, and each go-kart and bike has 1 seat.
Okay, does anyone have anything they want to say to Abdul? Yes.
How do you know how many seats there are?
Okay, so you don't see anywhere on his chart. You might want to use this chart table idea, and would you insert a seats column? Oh, he wants to have a seats column too.
Okay.
Alexa, show us yours again. Okay, come over here and stand by Abdul. So 2 different ways to organize this data, because you have a lot of data you have to consider. Okay, stand by Abdul. It's like show and tell. It's like sharing, right? Okay, turn around and show the camera. No, the camera. Okay, so in this case, tell me your name, hon. Kenny. So Kenny was suggesting there might be some place to put a seat to keep track of the seats, because that's kind of important. Yes. Oh, what do you mean by that? Say more about that. Okay.
Because like a key or a legend shows you what the symbols mean.
Okay. So Abdul's counting right now wheels, and at one point he has to consider seats. Alexis is doing it all at the same time. She's saying seats and wheels, seats and wheels, seats and wheels. So you have 2 ways you could start. Okay? If you're a little stuck, one of the things that helps me is this idea of a math model. Get it out. See if you can get all the pieces out.
No,
Okay?
you have 4 seats, and then you have 12 wheels.
Okay, so say that again. I was a little confused.
If you have 2 bikes,
Okay, you have 2 bikes.
then you have 4 wheels.
If you have 2 bikes, you have 4 wheels. Okay, I'm going to write up here so that I can be clear what you're saying. All right, so if I have 2 bikes, that's going to equal 4 wheels. Is that what you're telling me? Okay.
And then if we still have 2 bikes, then you're gonna have 2 seats.
And you have, okay, so I'm going to say that the number of the vehicles is also going to be the number of seats. Is that correct? Okay, now what?
And then if you have 4 go-karts,
Okay, so I've got 4 go-karts.
then you have 8 wheels.
It's going to be 8 wheels.
8 seats.
Is that's going to be 4?
No, 8 seats.
Okay, oh, so you have 2 go-karts. Yes? Okay.
2 go-karts, and you're gonna have 8 wheels.
2 go-karts, 8 wheels. Okay, so let me ask you a question. If you need to have 21 seats, can you have the same number of go-karts and the same number of bikes? Why not?
Because
So you guys are done, so let me ask you this.
21 is not divisible by 2, and bikes have 2.
And I am not riding a one-seated bicycle, not happening, okay? Or a half-a-seat bicycle and a one wheel, okay? I'm not doing that. Okay, so you know that these 2 numbers in your final answer will not be the same because 21 is an odd number, okay? So you're on it, just keep going, figure it out. You're gonna get close and then you might get too far and have to back up a little bit, go, ooh.
I did a table, and I kept going until I got...
How much go-karts are there?
Huh?
Did you get your go-karts yet?
Yeah, I got 6 go-karts and 15 bikes.
So you're adding them together. Show you
There's
how
a
to add
30.
together.
So 30,
You're gonna do like
there's
this.
30 wheels
Add together.
and 24 wheels, and these 2 added up equals the 54
Teacher said
wheels.
you have
And
to show what.
so, and down here is the seats.
She said that's
How many seats are 6 go-karts?
6.
How many wheels are 6 go-karts?
24.
Okay, and then what's your other part? So you say you've got 6 go-karts, and your 6 go-karts are 6 seats, 24 wheels? Okay, and then what's your next part?
And 15 bikes.
You have 15 bikes, and you have 15 seats, and 30 wheels. And how many seats are you supposed to have all together?
54.
And how many do you have? How many seats are you supposed to have all together?
21.
How many seats do you show?
21.
How many wheels are you supposed to have all together?
54.
And how many wheels do you show? Sounds good. Sounds good. The problem that they had with the wheels and the bikes and the go-karts, it was fun watching them pick up different strategies. I had students set up tables. Knowing that a table was going to be a good strategy, maybe not being clear on all the components of their table that they needed to be able to solve it. And so that's when peer work really kicked in, because students were able to say, well, mine looks like that, but I also added the seat component, or I also added the seat part. Other students drew pictures with dots representing wheels and using the draw a picture strategy. And there were others that did guess and check, which I tell my kids, guess and check will always work. It might not be the most efficient, but it will work. But I think that they had that comfort level when they received that task of, okay, I can do something with this one. I know at least where to start. Might not know what I'm going to put in the numbers or in the boxes, but I do know where to start on that. Over time, I have emerged as a teacher who allows children to talk, but again, the math generation and the value of listening to children explain why they're doing things and what they're doing, I think is really valuable. I think to me, that's the biggest piece that I've taken out.